Now let's do a summary of the inverse functions, looking at their domains, ranges, and what the range of principal angles especially are for each of the functions. So inverse sine is a function that has a domain of -1 to 1 and a range of -90 to 90. So that means the trig values can only go from -1 to 1. The angles, the output value, can go only from -90 to +90. Now I'm not going to test you on what this graph looks like, but just to remind you, it's just a portion of the inverse sine curve, and the portion looks like that. It curves. We have a piece of a curve here for quadrant 1 angles from 0 to 90, and for angles that would be, or sorry, we should say for positive trig values, we give angles from 0 to 90. For negative trig values, 0 to -90. So if we are to look at our circle diagram, in our circle diagram, with our angles around the circle like this, when I refer to the quadrant for the principal angles, I'm referring to the quadrants on the circle diagram for angles. So quadrant 1 is a positive sine value, and quadrant 4 has a negative sine value. And actually, I'm going to erase the 270, because really what I want is -90 here. I'm going to be looking for the angles closest to 0 that have a positive trig value and a negative trig value. So my principal angle is always going to be in quadrant 1 or quadrant 4 for inverse sine. And if it's in quadrant 4, it's going to be a negative angle. Now let's move on to inverse cosine. Inverse cosine has the same domain as inverse sine, because both adjacent over hypotenuse and opposite over hypotenuse have to be contained in the interval -1 to 1. But the range for inverse cosine is 0 to 180. So when I make a little sketch of my inverse cosine graph, I don't have anything below the y-axis. I have 0 here, I have 180 here, and then right in the middle would be 90, and the graph kind of curves like this, and has its endpoints at 0, 1, and 1, 0, and -1, 180. So the principal angles for inverse cosine are in quadrants 1 or 2. If we're in quadrant 1, that would be in getting a positive trig value. That's going to give me an angle between 0 and 90. If I have a negative cosine value, that's going to be between 90 and 180. Now let's look for inverse tangent. Inverse tangent has a completely different domain than either sine or cosine, because in an inverse tangent graph, and this is in the wrong place, this tangent here was supposed to, let me get this word tangent here was actually supposed to be over here. So let me write that where it's supposed to go. So inverse tangent has asymptotes at positive and -90, and the graph for the inverse function is contained between those asymptotes, curving like this. So its domain is actually all real numbers. I can put any value in for a tangent value, because opposite over adjacent can be greater than 1 or less than -1. It can be a bigger number than 1. Its range, however, is very similar to sine's, -90 to +90. It's just the endpoints are not included, because that's where tangent is undefined. So that's why we use curved brackets instead of hard brackets. So the principal angle for inverse tangent is also in quadrant 1 or quadrant 4, and once again in quadrant 4 we'd be using a negative angle, because we're looking for the angles that are closest to 0 when we do principal angles. So if we get a positive tangent value, once again we're always in quadrant 1 for positive sine, tangent, or cosine values when we do inverse functions. But if we have a negative tangent value, then we're going to go backwards into quadrant 4 and go from 0 to -90. We'll come back to this information in our practice problems in the next page of the notes.